It's time for another math easy solution. Trying to discuss a quick example on orthogonal trajectories. Basically, in my earlier video, I went over introduction to it, so I might as well illustrate it further with using another example. Basically, the orthogonal trajectories, just to recap, it just means they're perpendicular trajectories. If you have a curve like this, and another curve, basically at every point, you're going to have a perpendicular line or a 90-degree line. And basically, the example says here, show that the family of curves below are orthogonal trajectories of each other. And these are the two curves, xy equals c, where c is not equal to 0, and x squared minus y squared equals k, where k is not equal to 0. So these are both hyperbolas. You can see my video on hyperbolas in the video links below. Basically, this curve, these curves right here, y equals c over x. This one's x squared minus y squared equals c, or I'll just use k in this case, equals k. So these are these curves like this, and going from up and down here, and then the other ones are like this. As you can see, basically the question is asking, prove that at every point you're gonna have perpendicular at every time they cross each other, or that they are basically orthogonal trajectories of each other. Yeah, just once again means perpendicular trajectories. It just every time they intersect, it's a right angle there. And to prove it, we have to show that they are the derivatives are negative reciprocals of each other. You see that in the video link below on proof of that. What I mean by that, I'll just go over this. To solve this, we have to find the derivative of this and the derivative of this, and then compare the derivatives. So y prime here and y prime here. And to do that in this case, we could just use implicit differentiation. We could, yeah, it's much easier than solving for y. So we'll just do that for the first one first. And remember, c is just a constant. This could be 1, 2, 3, 4. That's why you have several of these. This could be for 1, this could be for 2, it could be for 3, and this could be for k equals 1, 2, 3, etc. So it just doesn't matter what it is, just a constant. So now we'll have, let's go xy equals to c. Take derivative of both sides, d over dx. In terms of x, d over dx. Right here, so the right side is going to be equal to 0. Over the left side, we're using product rule. You see proof of product rule in the video link below. We take derivative of x, which is just 1, times it by y, then plus derivative of, no, let me just put x derivative of y, which is just y prime, which is what we're trying to solve for, and the right side is equal to 0. So solving for y prime, we get y prime is equal to, shift this to the right side, negative y, then divide by x over x. So this is a derivative of the first one. So this is for xy equals c. And now the second one, where we have x squared minus y squared equals to k. Now we take derivative of both sides, so d over dx using implicit differentiation. Again, you can see more on implicit differentiation in the video links below. And now, so we'll have this. Now take derivative of the left side, we get using power rule, bring that 2x down, so then minus the, yeah, so basically that's derivative of x squared. Now this one here, bring the 2, then we have y, then using chain rule, y prime right here. And now this equals to the derivative, this is constant, that's going to be 0. So now we solve for y prime, we move this over to the right side, divide by 2, so we get x equals 2 y primes, move this over and divide everything by 2. And now we solve for y prime, we get y primes equal to x over y right here. So now when we compare the derivatives, this is y equals negative y divided by x, so versus y prime is equal to, this is negative y over x. So this is the negative reciprocal. Yeah, so basically I wrote this down, y prime of k. This one is just representing this the derivative of this function, x squared minus y squared equals k, and this one's the first one, that xy equals c. They're both negative reciprocals of each other, thus are orthogonal. And you can see a video link on negative reciprocals. What I mean by that is basically if you have a function y prime, if this is the derivative, the negative reciprocal is going to be negative 1 over y prime. And that's basically what we see over here, where there's an xy, so we flip it and put a negative, so we have negative yx right here. And you can see the proof that this becomes orthogonal, or at 90 degrees, or right angle, or perpendicular, etc. So this is our proof, and we basically solve the example. And then this is the proof that at every point at every intersection, there's going to be a perpendicular line, and this comes up in physics a lot and other stuff. So this is pretty interesting, and also required in a lot of physics and math. Well, anyways, that's all for today. Hopefully you learned from this, and remember you can download these exact notes in the Dropbox link below, and stay tuned for another math easy solution.